So recording started. We've been advised to advise you if you don't want your image to appear, just check if you have your camera on. So if you don't want like having your image in the record and turn your camera off. If you don't mind, then leave your cameras on. I see most of you leave your cameras off anyway. But that's not to say we want you to leave the camera off. Just to say if you don't want, so make sure it is off. Well, I think I will start with the lecture, and I think it's easy for people to catch up if they log in a little bit later. So today we will be looking at national material accounts, uh, which you probably now you will find a lot of similarities between the several sustainability assessment methods. Each of them have their own characteristics, their own features, which are quite distinguishable. But a lot of the things, they are at least close to each other in terms of how you report it to functional units and things like that. So in terms of national material accounts, we will discuss a lot about it today, but in the end is another way of looking in terms of a footprint, but in this case, it's like a footprint of material requirements. Let's start it, and then we will explain better what it means. Just acknowledging that this material has been based on material from previous lectures, Ruth Fisher and JP Gaitan and Stephen Moore. So I've built upon their material, and I'm very grateful for what they've done before. So this is overall content that we'll be looking today. So as with pretty much everything we've been seeing now, our conceptual framework is something like this. And just as a matter of curiosity, if you look at this, you can relate it back to that first lecture that I gave when I spoke about that cool differential equation that involves balances. And I said, well, that's the basis for pretty much all the accounting that we do in terms of environmental balances. And this is just another way of writing that same thing. So when we think of how society or the economy works, in terms of requirements from the environment, if we look at physical requirements, we look at two basic things, which are materials and energy. So economy or society requires an input of materials from the environment. They require extraction of materials and harnessing energy from some source. We'll do a lot of things with that, and this will go out to the environment again at some stage. Here it looks very simple, one input, one output, but in truth, we have so many inputs and so many outputs. So what material accounting, and then today we'll be looking at national material accounts and material input per unit service. And in the next class, we'll look at material flow analysis. But all these material accounting techniques, what they do in principle is trying to map these material inputs and, equally important, map the outputs, quantify them to some degree of detail. And grossly speaking, the differences between the different material account methods is basically the level of detail that you can break down the inputs and the outputs. So the idea of material balance is because the mass of materials is conserved. If we look at our global environment, we can neglect any exchanges of mass with the outer space, right? So there is, in fact, particles that come from space, and the atmosphere also loses some particles to the space, but that's irrelevant for us at the moment. So basically what we can think is that all materials on Earth, they conserve. What changes is where they are and their state, and even their chemical composition will change a lot, but the total mass of materials on Earth conserves. So what we try to do is to close that balance within a given system. Today we will be looking at that balance at national level mostly. So looking at how these national economies relate to inputs and outputs of materials from nature and from one country to the other. Also, we will look at how the supply chains of a given product can be mapped in terms of uh, a mass or material balance as well. So this is not only for national material accounts, it's just a concept for material flow accounting as a whole, which is just what I said, just tracking these inflows, outflows, and the exchanges of materials through the economical process and through society, because if you consider the consumption and all things. And also we will be focusing on losses, all right? To close the balance, we have to look at the losses. And besides being important for closing the balance, what's the environmental implication of these losses? Like if you have a supply chain and we have materials coming in and materials being lost along the way, what would be the environmental concern related to that? Can you suggest any? Anyone volunteer to suggest any environmental concern about, materials which are lost during a production process or a whole supply chain? Yes, so one of the like how they can be lost is by leakage, and so elaborating on that, which would be the environmental implications of these leakages, what you can imagine? Yes, so one of them is potential contamination. So maybe the materials which are lost along the way, they are lost to the environment, and maybe they are not that beneficial to the environment where they are dispersed. So I think very good. You guys built upon what each other said. So one of the concerns is pollution or contamination of the environment, because many of these losses will be uncontrolled and to the wrong place, let's say. A second concern is in terms of efficiency as well. So mapping the losses helps us understand where the inefficiencies are. And the third concern is in terms of opportunities. So mapping the losses or mapping where materials are discarded may help us understand potential opportunities for then using those materials as input for different processes. So in terms of integrating the whole production with that concept that we saw before, which is called the industrial ecology, right? Which is when one industry can uptake what would be the wastes of another industry so that they can uptake that and use their products. Very good. And then from a global, like from a more general sustainability perspective, we do that to understand or to compare, to balance uh, the actual use of natural resources, which is what material accounting does. Like it's a way to characterize and break down and map how we use natural resources in terms of materials, and then compare that with the capacity of the environment to supply those materials and to absorb the wastes, which are the losses and the final disposal after the products are consumed. So in one sense, this this has a parallel with what we saw before in terms of ecological footprint. But if you want to do a main distinction here is that in terms of ecological footprint, we were looking at ecosystem services, right? How the productivity of the biosphere, productivity of the living organisms can supply what we extract from these living organisms, not only in terms of material, but in terms of services as well, such as carbon absorption and so on. In here, we are looking at materials. Includes also biological materials, so we would include, let's say, wood or crops or other things in these material balances. But here we are looking at in terms of mass of flows, like we extract this much from the nature. And in here, we do not characterize how much nature can supply. It's just more to understand how much we are demanding. And another difference here is that we are looking not only in terms of biological materials, but we're looking at all types of materials. Uh, with one exception that we will see later, but we look at all types of materials, including, and I would say maybe with a very good focus on non-renewable materials. So fuels or fossil fuels and minerals and ores and precious stones, precious metals, and all things like that. So this is another difference comparing to ecological footprint. Another practical difference is that this one it's characterized in terms of mass. Ecological footprint is characterized in terms of area of ecosystems. So just to give some idea, just to make us like, doesn't sound we're talking about the same thing. We are not. It's a different focus. And then is another way to look at a physical basis of the economy. And it is an indirect, or maybe direct, but a very basilar indication of environmental pressure, environmental burden, with the idea that as many materials we require from nature, it means, in principle, this is correlated with more degradation and more depletion of the natural resources. And on the other hand, on the other side of the chain, it's related to more wastes being generated. So it's looking at a very like aggregated way of characterizing a certain pressure in the environment. In this case, the pressure of extraction of natural materials and generation of wastes. So there are several methods to do this, several ways of doing this characterization. Today, we will look at three methods. One is the economy-wide material flow accounts, which is what we will dedicate most of our lecture to it, which is, as I said, a characterization of these material requirements for a country's economy. That is also what we call a material footprint, which one of their methodologies that support these material footprints are the input-output tables that we discussed a little bit before when we talked about ecological footprint. And also, I believe Sue addressed it quite well in her content. But there are other methods that we will see also for material footprints. And finally, what we call the material input per unit service, which is, instead of looking at a global economy, we look at a given product or a given service, how much of material burden that product involves. So, as I said, most of our class today will be looking at the economy-wide material flow analysis, or also what we call the national material accounts, which is when you do this accounting for the each country's economy. So it's all of this is basically accounting. It's just a way of computing flows. And then in terms of this economy-wide material flow analysis, we are looking at inputs and outputs and internal consumption and accumulation in each country's economy. So most of the cases, this analysis is done for national economies. It can be scaled down to state economies, local economies, but what we will see is that in most of the cases, the data, the quality data which is available is more at a national level at best. So scaling it down sometimes will be challenging, but the framework would be similar. So if you have then enough detailed data to do that, framework can be directly applied to smaller areas. So, and here are the exceptions that I mentioned before. So the idea is that we look at all materials flowing through the economical chain. So these include solid and gaseous and liquid materials, as I said, both from biological sources and from non-biological, non-renewable sources. And the only exception here is that for this framework, we do not consider consumptions of water and air. So there are separate uh, environmental indicators for water and air. Okay? And the reason why would be just because water and air would just dominate the indicator. Because as you can, like for water, it's simpler. We know our economy requires a lot of water. It requires water for irrigation. It requires water for industrial processes. It requires water for drinking for us and for animals to drink. So it's a lot of water that we require. And you may not realize it, but our economy requires a lot of air. Of course, we require air to breathe, but the economy as well, because a lot of the things we do in our current technological system is based in burning. And how do you burn things? You need oxygen. So all the industrial boilers and the furnaces and all of these things, they require fuels. We know we consume a lot of fuels, especially fossil fuels. But to burn those fuels, we inject a lot of air. We need oxygen, but the cheapest way of having oxygen is injecting air. Oh, besides burning, we also use air in several industrial processes that make reactions with the air, or even production of liquid nitrogen, where you then take the nitrogen from the air, condense it, and then uh, sell it or provide it as liquid nitrogen. Uh, for biological processes such as fermentation and for the wastewater treatment, we inject air there. So we consume a lot of air, basically. So because we consume so much of these, and because the environmental dynamics with water and air, they are very particular, uh, these indicators don't include the requirements in terms of water and air. But besides that, all the other materials in principle should be included. So this is just what we explained before in terms of those exchanges from the environment to the economies between different countries back to the environment all over this chain. So this is like a simplified framework of, requirements from the, like if this is a national economy, you would have extraction nationally, things that you take from your national environment, physical imports. Then we have what we call indirect flows associated with imports, which is extraction from the environment, which were done because of these products, but they do not come physically to the country. Then you have what is accumulated in the economy in that given time period. So not everything that we take from nature, we discard it straight away. We may keep it in our economy for a while as durable goods or construction materials and other things. We also have recycling, which means we are reusing things which have not been extracted in this time step. It has been extracted before and we are keep using them. And in the end life of all of this, we have outputs through the environment and also outputs through a different country. This is a simplified framework. A more detailed framework in terms of national accounts, it's like this. So in this case, we exclude air and water, as we said. Air and water, we treat them different. So it's not included in the national material accounts. And it's the same thing. And in here, we also detail what we call an unused extraction and the actual used extraction, which we'll discuss later. So this is just to have an idea of how it's being extracted. So we're looking at this, things which is being extracted and have entering the economy. Just to give you an idea how this is evolved in terms of different types of materials, globally speaking, uh, along the years. So what we see is that our extraction from the environment is steadily increasing. The rate of increase kind of changes along the time. So here is steady, then kind of plateau, increase again, plateau, increase again, steeply increase, plateau, increase again. But overall trend is like we are taking more and more and more materials from the environment. And here we can see how it changes. See how much minerals we take. So all categories, they increased with the time, but non-metallic minerals increased a lot, and that may be related to many things, but our increasing consumption of electronics, which requires silicon and other non-metallic minerals, and also fertilizers. Sometimes certain fertilizers that are extracted as minerals from the environment, and also construction materials, which are most of them are non-metallic minerals. And then metal ores also increased a lot, and fossil fuels and biomass. So here is now the aggregator of all those materials, but looking at different regions of the world, what we see is that massive increase in the Asia Pacific, and it's clearly explained by the economical growth and the industrialization of China, of course, and other countries as well, like Taiwan and Indonesia, and all of these countries, they've industrialized a lot in the 70s and 80s. So we see that being reflected here as more extraction of minerals, or not minerals, sorry, of materials. Whereas we see that, what is Europe? So Europe's pretty stable because their economy is kind of, the industrial activity kind of plateaued. So a lot of what we will do today is to look at concepts. And I apologize beforehand that it sounds a bit boring, like just, well, what this term means, what that term means, but I would invite you to look at this from a different perspective. So let's think that all of these terms, they were defined for a given reason. So understanding their meaning, it helps us understand one aspect of these burdens over the environment and one aspect of these economical dynamics, these flows of materials through our economy. Okay, and later we will see how we can use these concepts to characterize and then monitor changes in terms of material requirements. Okay, but now for a few slides we'll be just defining terms, and they look all similar, so it's kind of, it takes some time, like you have to come back again and again um, to get familiar with the differences, because sometimes just like, oh, this one includes domestic, or includes the unused materials, this one doesn't include, or this one includes the physical exports, this one includes the raw material equivalent of exports. So some of them, they are different for in terms of details. So it's kind of, it takes time. I expect you have to revisit a few times to then get familiar with what each term means. So the first one, which is used quite a lot, is what is called the direct material input. So I find this diagram here very useful. And by the way, I find this source here very useful. It is on Moodle, this Eurostat document. We will talk about Eurostat later, but Eurostat is like a institution from European Union, which does accounting, like national accounts, not only in terms of material, but several national accounts for their countries. And one of the accounts that they do is exactly the national material account. So possibly is the best example in the world of this being done systematically and consistently. So their material is very useful to understand all of these concepts and to see them being applied in practice. All right, so what is direct material input? It's just when we say the direct, normally we are talking about materials which are used in the economy. Okay, so it's basically what we call domestic extraction, which is the extraction that happens in the territory of that country, and it's all the materials which are extracted and enter the economy, so enter the industrial processes, plus the imports. So it's basically like the materials that this national economy actually uses. So this is what direct material input means. So basically it's the sum of what we call the domestic material flow with the foreign material flow, which are used for direct processing the economy. Okay? Then we have something which is called the domestic material consumption, which then tries to map the materials which actually are used by the internal demand. So basically it is the materials that enter the national economy minus the material which are exported. So the materials that are physically sent somewhere. So basically you say, oh, this entered the economy, this was sold to another country, whatever the difference is what we actually consume in the country. So mathematically speaking, is the domestic extraction plus the physical imports minus the physical export. When you say physical, it's just the actual products which come in and go out. Then comes now things start to get interesting, which is when we start to think about what is not directly seen in the economical process. So when we start to think about what we call the hidden flows, which are those materials which are extracted and or disturbed in the environment. So it means some level of environmental degradation or environmental impact in terms of moving or extracting materials, but they never enter the economical process. So they are way more difficult to quantify and way more difficult to realize they are there. So giving concrete examples of this, we break them into different types of materials. So one of them is called ancillary material, which are materials which are actually removed from the natural environment, but then they don't enter the main industrial process. So, for example, if you're looking at logs, wood logs for construction or paper production, whatever you're gonna do with them. Normally, you will cut a tree, right? So you cut the tree and you transport that tree somewhere, or you maybe transport only the log, but you will not use the whole tree. So the smaller, no, the branches by the mostly will be cut out. The leaves, of course, go with the branches, and the bark sometimes will not used. But all of these things, they've been extracted from the natural environment. But when you look at the industrial process itself, they don't get in the industrial process. They are discarded before the industrial process. So if you only map the economical process, those branches, leaves, roots, and all of those things, although they were an environmental extraction, environmental impact, but you don't see them in the economical process. So you cannot account them by looking only at the economical chain. And sometimes also happens with mineral ores, like you were looking at the ores, but the ores come with a lot of other materials like soil and other things aggregated to them. This gets discarded before the ores are processed for the precious metals or for the metals like iron or manganese or aluminum or other metals. All right, so I think this is one of the hardest concepts to understand. So if you have questions, please feel free to bring them in. And another thing is materials which are not even actually extracted from the environment, but they are disturbed in the environment. So the main examples that we see is what we call the overburden for mining, which is to go and extract the ores, to extract the, you know, the minerals containing your product of interest, be it iron, gold, silver. But to do that, you dig a big hole in the ground. So to dig that big hole, sometimes you just move the soil, the land from here to few 100 meters away. So you're not actually extracting that away from its original environment, but you are disturbing it in the environment. So you degrade that amount of materials. It's degraded there, so it doesn't serve its natural purpose anymore. But that not even goes away from the site, so it never enters the economy. And again, it's very hard for us to quantify for that disturbance. Other examples are, for example, soil erosion. So if you look at the material flows from crops, you tend only to think about the crops themselves. Okay, you cut the crop, you bring it for processing. But by introducing that crop, you have erosion from the soil. So there is actual physical mass of soil being disturbed and moved away. And if you look at specific components of the soil, some of them will be more carried away than others. So you can look at loss of nutrients and things like that. But again, those losses never get in the economical process. So again, it's hard to quantify about them. So these are examples of types of hidden flows. And it's clear for us why we call hidden flows, because it's hard for us to see them when we look only at the industrial process. Questions about this? Normally people have questions about this. If you have any questions later, feel free to pop them in and we can come back to this. So we have some special names for these hidden flows depending on how they come. So if these hidden flows, they are from the domestic economical activity. So if they happen inside the country's territory, we call it the domestic unused extraction. So remember, when we say domestic extraction, normally we are talking about the domestic used extraction, the things that actually enter the economical process. But we also have the hidden flows associated with that happen inside the country, and we call it domestic unused extraction. And there is the upstream material flow, which comes with the import. So if you import things, you have the actual physical products we import, but you have the hidden flows that happen in that country. So this is what we call the indirect flows. Yes, so there are methods. So our friend here asks if there are methods to account for them. Yes, there are. So that's what we will see exactly now in some of these indicators. Yes, there are methods. Yeah, discussing these methods, we'll discuss them later, but people try to account for this and to create concepts and indicators which incorporate that as, in the view of these people, a better indication of environmental burden and environmental pressure. So one of the main indicators is exactly this total material requirement, which is all the material input needed by that economy plus all the hidden flows, both domestic and imported. So basically this, except water and air again. So basically here, and don't get confused with this because some people find it confusing that this is inside, so they think it's being excluded. No, this is also accounted. So the total material requirement means the physical imports, the domestic extraction, which is used in the economy, The domestic hidden flows, which are those overburdens and ancillary material which never enter the economy, but they happen uh, in the domestic territory, plus the hidden flows that happened in the countries where the import materials were extracted. So this one is like a possibly the most like the broader indicator of environmental pressure in terms of requirements for this national economy. Okay, so this is all the inputs in terms of all their environmental material extraction. So here, schematically, we see it's the sum of all the direct flows, domestic and foreign, and all the hidden flows, domestic and foreign. Okay, which are the ones which are, oh, sorry, I pointed this opposite. So all the direct processing flows and all the hidden flows, both domestic and coming in the imports. And then when they do that, they try to break it down in different material categories, as we saw before that example, which has ores and biological materials. So the typical categories that they look at are fossil fuels, metals, industrial minerals, which are like non-metallic minerals which are used in the industry, construction minerals, which are then non-material metals which are used in the construction industry, and biomass. So these are the main categories that people normally break down. So they try not only characterize all the total mass of materials extracted by the environment, but trying to understand which types of materials are being extracted and are being exchanged between economies. So we discussed about this before, but basically what we expect from doing this. So the argument in favor of this total material requirement accounting is that it will be the indicator that covers most of the material requirements in terms of all that overall environmental pressure in terms of extracting materials to supply for the activities in a certain economy. But the thing is, it is not a direct indication of environmental damage, right? Because we know, like, vaguely know how much of materials is being extracted, but we don't, it's not directly related to how much impact that caused. Because how much impact that caused will depend on what you consider impact to start with, and then where that extraction happened, which method was used, which type of pollution was generated. So all these details, they are not included in these indicators, all right? Because as we said, normally the wider you try to do your accounting, the less detail you have. So with less detail, you cannot do this direct environmental impact assessment. But if you think that any materials that once we extract from nature, at some point in the future, it will return to nature in terms of wastes or pollution or emissions, then we can understand this total material requirement indicator as like a measure of a overarching burden in the environment in terms of how much we had to take from the environment and how much waste we will produce at some stage, if not now, in the future when these materials find the end use. However, it's another important point, we do not know exactly how much each material stays in stock because it depends on a lot of things, a lot of dynamics in terms of how durable our construction is, how durable our use or our goods are, and then the user behavior in terms of um, how quickly people discard things as well. So this is just to give, we will pass quickly here, just examples of these accountings done, some old periods now, but still can show things. So this is again total material requirement, total flow of materials per capita per year. And here we see Australia has increased, like increasingly US decreased. Interesting. Some countries are stable. And later we can discuss what will lead the country to a decrease in the total material requirement, which is what we desire, right? In terms of environmental perspective, we want less requirement of materials in the environment. So this is just examples of in 1991, where most of you were not even born, and I had just been born the year before. Here we're looking at the distribution between direct inputs and hidden flows. And we see that for most economies, the hidden flows are the largest part of their total material requirement. So here already we can see how if we neglect hidden flows, we are missing a big part of the environmental burden in terms of material requirements. However, yes, it's, as we said, it's way more difficult to quantify these hidden flows, and there is much more uncertainty on that than looking at only the materials which are actually processed in the economy. Here's an example of Australia and how it has changed with years. So we see that, interestingly, the direct material input increased and proportionally increased more than the hidden flows, but there is still a lot of hidden flows here. And here is just showing, like how this changes with a population. And well, sometimes there is a correlation, sometimes there isn't. And that goes back to the discussion we had in our first class in terms of which pressures cause environmental impact. So we saw that yes, in overall terms, an increasing population increases environmental requirements, but then it also will depend on the level of consumption of that population and the technologies that you have, and how efficient you are in terms of environmental technologies. Again, now breaking down in Australia, this is direct material input. So this is materials actually used in the Australian economy and how it breaks down with different, all those categories. Here they go even more detail, and they break down the biological materials into like crops, animal products, forestry. And here they aggregate imports. So this, we don't know, imports will be anything. But we can see that a large increase of energy materials, which possibly will be the coal extraction, and a lot of construction materials too, which possibly construction material was to accommodate an increase in population. We also can see, and we will see this quite many times, and we will also discuss that in the tutorial today, there is an overall correlation with economic activity. So here we see in terms of energy use and GDP. So overall speaking, the more the economy grows, which means more money we do per person, more energy we use. And here we have two downs, and the downs we see, they're both happen in terms of energy, in terms of economy. And these were the two global crises that we had. So this is just breaking down the hidden flows in Australia, and then we see there is a lot related to metals and again, energy materials. This is just showing hidden flows and direct input in terms of domestic and exports. So of all the input, all the material requirement, how does it then distribute in terms of what is used domestically and what is exported? And we see that's pretty much half-half. So half of the material requirements are domestically used in 1991, and half of it was exported. And the exports increased a lot with time. So here we can track an Australian economy being increasingly an export economy. So here is a very interesting graph which tells us how the material consumption relates to the GDP, which is the gross domestic product. So they're looking at like these are percent changes. So we are looking at for a given percent change in the GDP, how much we change in our proportionally we change in the material requirements for the domestic economy. So this is domestic consumption. And two things to note here, we are not talking about all the economical activity happening in the country because we are neglecting economical activities that are done for export. Second, we are neglecting hidden flows. So this can be quite misleading because depending on the type of products you consume, you do not have a big mass of products being consumed, but they may be associated with larger hidden flows. We will see good examples of that later. But this is good to illustrate the concept of decoupling, which we'll talk about a lot about. So here is what we call the absolute decoupling, which means an increase in GDP with a decreasing or stagnated zero increase in terms of material consumption. So in principle, this would indicate that those economies, these countries here, they can grow their economy without increasing their requirements of extraction of materials. Again, if you put hidden flows there, you may see a different picture. So this is what we call a no decoupling, which means if you increase your economic activity, you have to increase proportionally the same or even more the material consumption. And this is a relative decoupling, which is in between, which is like, well, economy is increasing, but material consumption is increasing, but not in the same proportion. So the economy proportionally grows more than what we require of materials. So I find it very useful putting it this way. I think it's one of the best ways to illustrate decoupling. But again, if you change this in terms of domestic material consumption, if you change it for a material footprint or a total material requirement, well, not sure if this will be the same behavior, but possibly not. Here's just to look at how there is somewhat a correlation between material consumption and energy consumption as an indication of both materials used for energy, like for physical fuels consumed, which will then be accounted here and then will also be correlated with this. And also indirectly because like if you have larger economical activity, industrial activity, normally you have larger material consumption and energy consumption. Questions? No questions? All right, so we move on. If you have questions, let me know. Some more concept for us. So now are indicators of input. Because if you look at everything we're seeing now, they were to characterize the input the requirements for a national economy, right? So it's the total material requirement or the direct material consumption or the direct material input. So they're all in terms of inputs, what the economy of that country needs in terms of materials. So two useful indicators that we use are the overall material intensity and input material intensity, which is basically dividing the total material requirement by the gross domestic product, which is an indicator of economical wealth or economical growth, and dividing then the direct material input by the gross domestic product. And then, of course, there are details here. They normally use the gross domestic product based, not standardized, how you say, scaled back to a given year to account for changes in the value of the currency. So you eliminate that. So you want to see the actual economical growth or economical decrease. And normally you do it aggregated, but you can also disaggregate in terms of economical activities of different sectors. And this looks all in terms of the input of the economy. Do not subtract exports. So this is more in terms of, we're not looking at the domestic consumption, but we're looking at the requirements of that domestic economy. More in the terms of either if I consume it here or if I export, I need that for my economy to survive. So because the gross domestic product is related to all the money that this economy makes, so it makes sense also to include the money we make with exports. So it makes sense to include the requirement of materials related to the exports that we do. And this is just more of those things. Here's just to show relationship between the total material requirement and the direct material input. So what we see here at most countries, at least at that time in history, they had, as we saw for Australia too, their total material requirement is more, oh, sorry, the direct material input is less equal or less than half of the total material requirement. So the hidden flows account for more than half of the total material requirement, which then shows that if we neglect the hidden flows again, we may be missing a lot in here. And this is to show how countries changed from, well, most of them 1975, but then some of them different years, but how they changed in terms of GDP and total material requirement. So ideally, a decouple activity would be something like this, somewhat, where the GDP increased, but the total material requirement decreased. And anything that has a uh, less inclined, better. And here again, similar things, but now looking at domestic material consumption, again, not neglecting hidden flows and neglecting exports. And we see how different countries change. And as an overall rule, we see that some of what we call mature countries, which are countries being industrialized for longer time, they have this stabilized or decreasing, exception for Australia, which has a massive increase. And but many of the developing countries, they have a steady increase of their material requirements. So this is a very interesting graph, which shows what is making these increases. So remember, we discussed about, again, in our first lecture, we discussed about which are the drivers for economical, or for environmental degradation, or from environmental demand. And the drivers were, overall speaking, population. So as I said before, population growing, you have a overall trend of more requirement. What they call here we call it the affluency, which is like how rich that population is, pretty much. So it's divided by the GDP, it's given by the GDP per capita. So with the idea that as more money you have, then potentially you can consume more, then you would have more environmental demand. And here, what they use here is a T as an indicator of decoupling, or couple of decoupling. So the T here is how much your economical growth is linked to a demand of materials. So it's like one of those intensities, but now in terms of domestic consumption. And here we can see that for most of the regions of the world, normally they have a trend of decoupling, in the sense that, yes, for the same unit of GDP growth, you can have less material requirement. But then in many of these regions, you have a increasing population and a population getting richer, so consuming more. So even if per unit of money, you need less materials, you're spending much more money consuming things. So then it goes up. So exceptions are like here in the Pacific, where part of the thing is because then there is still not much decoupling in terms of the economy, and here too in the Northeast Asia. But I find that graph very interesting because it kind of tries to break down what is driving those requirements. And here is a nice text. I will not go reading it here, but I ask you to have a look at this. Also, we will be discussing about this in your workshop today, why decoupling is important. But I think for most of us, based on the discussion we had so far, it's pretty clear that if we keep growing the economy, which is good and necessary for many parts of the world because people still need a lot of improvement in their life quality, and some of this improvement, sometimes a lot of this improvement is linked to having the money to be able to achieve that. We have to have economy growing, but we cannot sustain this level of requirements from nature. Same as we could not sustain it in terms of environmental footprint or ecological footprint, we will see it doesn't look sustainable in terms of so much material being extracted from nature. So soon we will have a break. I'll just finalize these indicators. Output flows. So now we'll be looking at, we will now look at everything that is like required for the economy in terms of natural materials. Now we will look at, well, after these materials are consumed in the economy, where do they go? Because as we said, we are interested to map inputs, but also we are interested to map the outputs because these outputs are also related in themselves to environmental impacts. So let's look at some of the terminologies here. Domestic processed output. So this is total weight of materials extracted from the domestic environment and imported from other countries, which are used in the economy, then flow to the domestic environment, right? So this is, if we come back to this, is this one. So this is like basically the emissions in the country's territory, okay? They come from the economical activity, and then these are emissions which happen in the country's territory, all right? Then we have domestic hidden flows, which are related to those hidden flows initially coming in the economy. So basically, if we look at hidden flows, all the domestic hidden flows that input the economy, they output the economy, right? Because in the end, they never enter the economical process. So these are like all those material extraction and movement and disturbance in the environment. So they are accounted both as the input and as an output in terms of environmental impact. And then we have a total domestic output, which would be the total, I'll use the term loosely, but the total environmental degradation related to material requirements in the country's territory. So this would include the hidden flows, hidden domestic extraction or unused domestic extraction, plus the process output, which is the emissions that come from the industrial activity or the economical activity. And then we have something that we call gateway flows, which is a part of this domestic product output or the total output, which are it's try to map where these outputs go, basically. So where the emissions happen. And normally we divide them in emissions to air, land, and water. And we can also look at how these outputs are related to given activities or given sectors of the economy. So this is also important because then we can map which sectors produce more impact, and then we can also look at those input-output methodologies where you can then look at how you can attribute the impacts from this sector to the consumption of other sectors. And another interesting concept is what we call the dissipative flows, which is a type of somewhat a type of gateway flow, but these are flows which are consequence of the economic activity itself. So, for example, if you have, I don't know, you build a house, all right? So you have materials there, and then you may think that the output, the environment will be when this house is demolished, and those demolished wastes will then be disposed in the environment. But in fact, during the lifetime of this house, materials are leached. I got a question here. I will address it soon. Looks like a very interesting question. So in terms of just finishing with the dissipative flows, like imagine like that with time, materials are leached from the house. You know, paints, the paints they degrade and they are leached, and then you have to paint it again. And also some contaminants are dissolved in water, or there is also abrasion with the wind, and dust is taken away from the. So all these flows, they happen during the either the economic activity itself or the use of the product, but they are somewhat unavoidable. So it's not like a flow that you can take control of it. They happen in a very diffuse way. Uh, Erosion will be another one, or leaching of nutrients in the agriculture will be another one. So these are example of dissipative flows. In terms of total mass, these flows are minimal. If you look at the breakdown, they will be little, but many of them are of very much environmental importance, especially if you're looking at leaching of toxic contaminants, heavy metals, bioaccumulative products, and so on. So that's why we look at them, because they may have, because of their quality, they may have environmental importance. Got a question here about, does the DPO include both positive and negative content to the environment? Could you clarify what you mean in terms of positive and negative? You mean if if they're good for the environment, or if they're bad for the environment? Is that what you mean? Just to make sure I'm responding the right thing. Correct. Oh yes. There is no characterization of the environmental quality of these flows. It's just like the total amount of materials going back to the environment. And then if possible, we break them down in terms of material types, but in the national material accounting itself, we do not attach to them any value in terms of like, oh, this is good or bad, or this will cause more impact or less impact. Not at this stage. Although that's a very important aspect of it, but it's not included in the material flow accounting methodology. And then there is something called net addition to stock, which is, well, we think normally these accountings, they are done by a year. You could determine any time step you want to do it, but then we have to recognize that not everything that goes in the economy in a given time step will go out in that same time step. So there is an accumulation, as I said, in terms of durable goods or construction materials and other things. So that is accounted as a addition to the stock. So it will be something which will be, for the moment, not being disposed in the environment, but as we said, with time, someday that will become waste. And then we can have a, uh, this depends. So colleague here asks, how long a product life is needed to be considered durable? This will depend more on what's the time frame of your analysis, right? So if you are doing what is the typical thing, a annual balance, whichever products are more durable than 1 year, then they will be an addition to the stock if they are not disposed of. Then you have to put them in the stock, and then they may become the output in another year. So this is just to show how the total domestic output, which is similar to the total material requirement, um, how that looks like, what it looks like. And then here we see that for most countries, the hidden flows dominated. Okay, so same dynamics behind the total material requirement. This is just showing we can also put an outflow intensity, which is just dividing the direct product output by the GDP. Now it's exactly the same thing, but now we're characterizing the emissions to the environment based on the economic activity. And we also want that to be decoupled, right? And here is like a breakdown of the total domestic outputs coming from different sectors. And we see that industry has a lot, and it varies from country to country. But we see that construction industry, energy normally is high, and agriculture sometimes. This is just an example of dissipative flows. So here we look at fertilizers, organic fertilizer, which is manure, pesticides. This is, salt, sand, and gravel. So if you have unpaved roads, normally you cover them with sand or gravel to improve uh, the traction of the cars in the road. But then with time, this gets carried away, and it's basically unavoidable. So it's one of those dissipative flows. And here's sewage sludge, because yes, we apply sewage sludge as a fertilizer as well. This is just to give an idea. And we see that they're really small. The other ones we talk about tons per capita. This one we're talking about kilograms per capita. But why they are important? Because see, we are talking about sometimes pesticides, fertilizers. So they are involved with environmental impacts. So this is one where the environmental quality of things comes more into view. Just showing how net addition to stock compares to the product output in the year 1996. We see that depending on the country, some countries have larger addition to stock, some country has smaller. So that would be an indication of both industrial activity in the country itself and the consumption patterns too. So just to summarize, what we see here is that industrial economies, they are becoming more efficient in the use of materials, which that means, in principle, a decrease in the output, and decrease in the amount of the wastes you generate, but it's an increasing trend. So becoming more efficient was not enough to see it decreasing systematically. And then we see that within a year, we have half to 3/4 of the resources being returned. So they split it to this. So outputs are normally larger than addition to stock. So this also reflects a consumption pattern. And then here is the other thing that we discussed about, which is the quality of these outputs. So besides how much is being disposed of in the environment, which is in itself a red flag, there is also the problem with what is being disposed and how toxic this can be. And also, yes, fossil fuel energy dominates things, as we can expect. And now we see how important it is to improve, to systematically apply these accounts and improve the level of detail for us to better manage this and better track the performance of countries. So just final comments before we go for a quick break. There is a system of environmental economic accounting which was prescribed in the UN summits for environment, which is they've already drew the attention to this need for better measurement of burdens or requirements of the environment capital. So all the things we are seeing now, they are included in this perspective, in this framework. And then they call for the development of national systems of integrated environmental economic accounting. So as you can expect, different countries do this to different degrees. This is what it would look like. So we first need basic statistics. We need, economical data, we need environmental data, and then in social demographic data, as you can expect. Normally you have good track of economical data because it is related to things that interest to people. The governments want to charge taxes, so they want to track very well who is spending where, how much where, so they can exact their taxes. Social demography, we have some degree of, depending on the country, you have more or less different levels of detail in terms of how much we understand of our population distributions and consumption patterns and all of that. And then when we go down to the environmental requirements, then this is where we need more studies, and we see that a lot of our indicators, they cannot be more detailed because we don't have more detailed data in terms of the environmental demands, as we discussed before. So something that I've mentioned before, I think the best systematic example of this being done is from Eurostat, which is this portal and this institution that takes care of statistics for the European Union. And they do a lot of economic accounts. So all types of accounts, and many of them are related to the environment. So here are some of them. And one of them is the national material accounts. So economy-wide material flow accounts for the European Union countries. And there are other ones here. So quick break until, let's do like a 5-minute break. So at 10:23 we come back to discuss the final part of our class. Okay, any questions before we go for break? Okay, so what decoupling and decoupling material means in this lecture? So here we are talking decoupling as the same thing, decoupling of material requirements or decoupling for us in that context is the same, which is just that idea that if you can have a economical growth, which will be indicated in this, typically it is indicated by growth of the GDP per capita, but you can see a decrease in the material requirement per capita. Okay, so maybe I will come back to this slide here. So here we are looking at domestic consumption. So we can look at the decoupling based on different indicators, okay? So we could have here a total material requirement. We could have here a, I'm sorry, uh, direct material input, or in this case, they report in terms of domestic material consumption, which is direct consumption of materials in the country. So the idea is that here, for countries where you have an increase in the GDP, increase in the economy, and a decrease in the material consumption, then you have a absolute decoupling. Then a relative decoupling would be if you have an increase in both, but proportionally you increase more the economy than you increase the material requirement. And a no decoupling is, well, any growth in the economy would need a proportionally equal or larger growth in material requirement. And again, here is like material consumptions, but we could do a similar analysis for all the other indicators of material requirements. We could also do an indicator for outputs. So we could look at a decoupling of emissions, meaning that an economy could grow, but the material outputs to the environment would decrease. That's basically it. Does that, did it clarify your question? Thank you. So yeah, in 3 minutes we are back at 10:23. Sorry, here we are again. So after break, thinking about it, did you get any more questions? So if not, we go to the next content, which is material footprints. So material footprints are another indicator which is similar or builds upon the national material accounts that we saw before. So this is more like looking at how much a product or a service or a sector of the economy has in terms of aggregated overall requirement of materials. And just to give an idea of some statistics here. So one person on average, like for the world average, a person consumes up to 8 tons of natural resources per year, so all summing all the material requirements. In Germany, the average consumption is 40 tons. And in other countries such as Burundi, Rwanda, and Bangladesh, consumption is 2 to 4 tons. So here is an example of what we discussed in our introductory lecture about intragenerational inequality, which is like different societies or different groups of people having different or requiring different demands from the environment. So basically, people in certain groups will be demanding much more from the environment, but then the environment, because it's a global environment, so everyone will pay that price somehow. And again, not that people choose to do like that, it's just from the economical dynamics itself, from the history and the economy of the countries. So again, we are talking about decoupling, right? But as we discussed before, if we look only at in terms of consumption, we may not reflect all of the things because we are not looking at first the hidden flows and second what happens in other countries. So sometimes if a country consumes a lot of industrialized products, the initial mass of materials required to produce those products is much more than the actual mass of materials being imported and consumed in the country. So again, if we look at domestic material consumption, which is where normally the national material accounts look at, we are looking at raw materials extracted in the domestic territory and entering the economy, so no hidden flows, then physical imports and physical exports. So in terms of material footprint, conventionally, they look at the domestic consumption plus the indirect flows related to the imports. So it's just a way to expand that scope to capture what happens upstream of these imports. Just to basically relocate consumption of materials which happen in another country, but that happened because the imports that this country uh, did. So this is their framework. Another way of look at the material footprint is with the concept of raw material consumption. So again, the domestic material consumption is derived from that economy-wide material flow account, but then here we are now accounting imports and exports in terms of raw material equivalents. So looking at the initial amount of raw materials which had to go into the industrial process to produce that. So here we still neglect hidden flows. All right, we are not looking at those materials which never enter the economy. Here what we are doing is just looking at the materials which actually enter the economy, but they are not there. they are not converted, or they are converted in products which are imported and exported, but they are not actually physically imported and exported. Okay, so what we see here is that both imports and exports are now in terms of raw material equivalents. So this is true. A portion part of that initial extraction, which then is associated with the production of these products which are imported or exported. So here is a schematics about it. So this one looks like that initial diagram that we saw, which is the direct materials, right? So we're looking at that domestic extraction and direct imports. But then for this accounting that we are looking now, we also consider the import in raw material equivalents. And then when we look at the exports here, we also consider not only the physical exports, which is this part, but then the fraction of the total material, or not total, sorry, the raw import material input to that country, but fraction of that which also is associated with the products which have been exported. So it's just a way to look at it not in terms of where the consumption of the materials happen, but where, like, it's a way to apportionate those material extractions to the products which are being consumed. And then when we look at this raw material consumption, then this becomes the material footprint of the country. So this is a breakdown of that, again, for European Union. And we see how, like, different types of materials can be broken down in terms of imports and exports. And here we see that when we compare the actual weight of imports and actual weight of exports with the raw material equivalents, the raw material equivalents are way larger. Okay, and the proportional distribution between different types of materials also change. So you can see here that in terms of physical imports, non-metallic minerals are small, but their proportion is much more when you look at the raw material equivalents. And same happens with the exports. And then comes the surprise. So if we had looked at the GDP growth, which is the blue line here, and the direct material consumption, we would have concluded some decoupling happened here, right? In the sense that the GDP grew proportionally more than the material consumption. But then if you redo this in terms of material footprint, which is just incorporating the raw material equivalents, then we see basically no decoupling. So sometimes you have an apparent decoupling because maybe you change the type of products that you consume. So if you consume highly industrialized products, the actual physical mass is not that much. But when you look at all the material requirements for their supply chain, for their production chain, then you have a different picture. So here is when this is redone for several countries, and we see that for many countries where we had an apparent decoupling, that decoupling is not apparent anymore. So this is an important aspect of that, and this shows the the usefulness of accounting for these raw material equivalents. And as we said, this still doesn't include hidden flows. The default material footprint doesn't include hidden flows. Maybe if we put hidden flows, even much more. So if we put hidden flows, then it would become a total material requirement that we saw before. So how do you do that calculation? There are different methods, increasingly being used input-output approach. And again, we understand why that is being used because it helps us map, basically, it helps us map the different sectors and their interaction. And then it doesn't have problem with system boundary, right? Because you capture those loops where things come from one sector, go back to another sector, then back to this sector in terms of a different product. Whereas if you try to do it linearly by just like a similar to a life cycle assessment, then you cannot do that because then there is a level of so far, like there is a limit of in terms of how far you can go in terms of breaking down the supply chains. But there are also different methods, like so this coefficient approach method is based on life cycle assessment type of things. So they look at different products, their supply chains, try to get the life cycle assessment of material inputs to their supply chain and make a coefficient for each product or each service. So there is this literature is available on Moodle. So if you look at that, they discuss the advantages and disadvantages of each of these methods, and they also talk about hybrid approaches, which is for where you have reliable data to do this life cycle assessment coefficient type of thing. You do it. Wherever it's not available, you then go for input-output analysis. So similar to maybe what Sue also described for her work. And this is just more of the same thing. There is this interesting article in the conversation where they talk about, are we actually leveling off our material requirements or just requiring the extraction to happen somewhere else and we don't see it happening here? And this is an example in terms of smartphone. So the actual mass, so if you import a smartphone, the actual mass of a smartphone is just this much. But then here is showing how much of materials are required in the lifetime of a smartphone, and that would be both the materials required for the production of this and the supply chain of these components, and also like the energy and things that you use to charge and use it. Questions about material footprint. It's similar to the other one. It's just saying that we are now looking at data which accounts for redistributes the material extraction depending on the consumption of the products in terms of international trade. Questions? So if it's real decoupling, the raw material equivalent will go down. GDP will go up, raw material equivalent will go down. It means that economy is growing even if its overall requirements, or not overall because it's not hidden flows, but its requirements when you consider also the supply chains in other countries still are not consuming more materials. Yes. So it would be either a leveling off or a decrease in material requirement with an increase of economy. So the last indicator we'll be looking at today is material input per unit service. So this one is like a breakdown through individual services or individual service units or individual product units. So basically it's similar to the other one, but now we are looking at not the economical output, but the service itself. So it's the total mass of materials required for producing a certain product or delivering a certain service divided by a certain unit that characterizes the usefulness of that service. So I don't know. And then this can change because depending on how you define the unit. But let's imagine, for example, if we're doing the smartphone thing. So we would look at the whole material requirement for the lifetime of your smartphone, and you would have to define a certain unit service for that smartphone. So it could be the number of smartphones itself, but you can also look at how many hours of use you had. Maybe it would make more sense. So I have this many materials required in the lifetime of this smartphone for me to use it for this many hours. So for each product, you will have a different types of service unit, which will reflect better the actual application of that product or service. And here, what makes this methodology interesting is because now they try to account for all the hidden flows, which they call ecological rucksack or ecological backpack. So they say that the total material input of that service of product is the actual weight of the product plus all the materials that were disturbed to produce it. So that would include the raw material extractions plus the hidden flows. And there are different scopes of doing this. Some of them we will also do separate for water and air. So finally, we are touching water and air. So here's just a breakdown of different materials that are required. So if we here we have raw materials, abiotic and biotic raw materials, used and unused. So this is the here used and unused, but this is still the ones that go into the economy. So we are looking at would be similar to a raw material equivalent. So it's like all the materials where they come from, but the materials which were actually used in the economy. Plus some erosion. So certain material footprints, here in this framework, they consider that a material footprint will also consider loss of soil from the economical activities, some will not. And then another scope would be to account of, again, here is exactly all the hidden flows. So this will be the erosion and all the movements, all the overburden and all the degradation, or not degradation, but all the disturbance in the environment related to the extraction of these materials. So this would be more or less speaking, a total material requirement. And then in this case, they also do separate indicators for water and air in terms of like a water backpack, they call, or an air backpack. So as we said, similar to total material requirement and material footprint. So material footprint will be more or less around here, or maybe here, depending on what you include as raw material extraction, but mostly will be here. Total material requirement will be somewhat around these 4 scopes here. And then in their case, they have different levels of disaggregation, or different levels of aggregation, different levels of scope that they can count. So again, as you can imagine, if someone talks about material input per unit service, they have to detail it very well to which extent they are doing this. Are they looking at everything? Are they looking at only this? Are they doing separate for water and air? So it's important to characterize that, because sometimes we will see that except for those standardized terms that are in the National Material Accounts Framework, all the other terms, they are quite loosely used. So some people would use the same term to say different things. And sometimes people do not realize they are doing that, so they do not define what they mean by those terms and confuse the readers. So here comes a advice for you when you're doing your assignments, but also when you're doing any technical report. Be very specific in the terms. Define what each thing means. Do not assume that people will know, because people use different terms for different, the same names for different things. In science, we have a lot of problem with that. Like in the type of research I do, like people have a lot of discussions just because they use different names and they think they're talking about the same thing that they're not. So these are examples of what is accounted in each one of those categories. And as I said, water and air, if they're doing separate, so we can look at consumptions of surface water, consumption of groundwater. We have air for combustion, air for physical and chemical and biological transformations. So in that case, they aim for looking at the whole requirements in the lifetime of a product or service. So it's like a cradle to grave approach, where they look at all material inputs in the lifespan and all the energy inputs, which then can, all the material inputs which were used to produce the energy, which then was used to produce this. So it goes as far as to map also the requirements from the energy sector, which has some relationship to the carbon footprint and the scopes for carbon accounting that Sue covered. But here it's not only carbon, it's like all materials. And then here is just an example of the unit service. So basically we do it for unit services just because if you do it for a product itself, given the same example of the smartphone that I said, maybe we have this much materials to produce this smartphone. Someone else produces another smartphone with less materials. But maybe the smartphone that I first produced, it can be used for longer. So I can use it for maybe double of the hours. So that's why we have to, the choice of the unit service should be very well made to reflect the actually usefulness of that product. Otherwise, you may come to some inaccurate or maybe not some very useful indicators of material inputs, because you have to see what exactly you want for that product or service, and ideally you would make your input, or you would then divide your input by that unit based on how much people use of it. And also in this framework, there is a space to do some qualitative analysis. So in principle, you could, depending on the characteristics of different materials, if they are more damaging to the environment or less damaging to the environment, you could attribute them different weights. So you could rescale our indicator based on the type of material you're consuming. So basically, it's like if my product uses 1 kilogram of sand or 1 kilogram of lead, the amount of material is the same, but then the environmental implications of those materials are completely different. One is, it causes harm being struck in the environment, but in itself it's not toxic or not bad. The other one is very toxic and bioaccumulative and causes a lot of problem. So you could then, by expert evaluation, attribute different weights to it, but for the moment, people have not gone so far. So this is just like a capability of the framework, but it's not being implemented yet. And then this, let's say the standardized way of doing this comes from a very famous institute called the Wuppertal Institute. Here is their website. It's very good visiting there. They produce a lot of these things. They have they are also involved with those factors for material footprint accounting, well, the coefficient approach. And so they produce these indicators for different products. So if you don't have any other source, you can use those indicators, but if you look at how they are derived, you have to be mindful of limitations. If you're doing it for a given product that you have complete understanding of the supply chain and the production chain of that product, you can also do an independent life cycle assessment to then map all the inputs, as we said, in terms of materials and materials for energy production. And you can construct your own material input per unit service indicator for that product. So maybe if you own an industry, or if you're doing environmental consultancy for a given industry, and you want to benchmark the efficiency of your product based on material requirements from the environment, and if your supply chain is not so complex that you can map it and reliably do a life cycle assessment, you can produce your own MIPS for that product. So this is similar thing, but now for food products. Just again, material input per unit service, breaking down different things. So here you see they have a separate indicator for water and air, and you can aggregate it or include it or not include it depending on the scope of your, if you want to do a total material input, you just can sum them depending on which scope you want to do it. So you can leave some, you can include or exclude them. So they can be used in principle as a preliminary LCA tool, just to do a screening to map which flows will be the most relevant ones to do a detailed life cycle assessment. Or if you have many products to choose, then you can like rank them based on these coefficients and then do a detailed life cycle assessment. There is a question here. What's the unit of the material intensity for food products? Good question. There is no unit here. Sorry, I apologize for that. I should have looked at the paper and put it here. I can't remember if it's tons by ton. I believe it is tons by ton of each product, but I'll have to check. But it would be like exactly, you know, amount of materials in terms of mass of materials by mass of products in this term. Possibly here we will be not sure if it's mass of the animals or number of animals. But I think the default will be mass by mass, similar to this one. And then, yes, can be used as a planning tool index. So if you have products which you think this indicator could map well their supply chains, so you can use that to choose which product do you consume, or if you have an industry and you look at suppliers, you can see which supplier is less material intense if you want to decrease your own industry material footprint. So which are the disadvantages? So several, as you can imagine. So one of them is uh, it's not, and this is a problem with all the material accounting techniques. They are not a measurement of direct environmental impact necessarily, especially in terms of pollution, because as we saw, sometimes a smaller amount of given substances will be much more harmful than larger amount of a different substance. And they have limitations. So they do not look at different surface uses. So we don't know exactly which type of environment is being impacted. So we're talking about how much material is being extracted, but you do not account from where this material is being extracted. So depending on the type of land, maybe if you are degrading a pristine forest like Amazon forest or bushland here, it's different than degrading an area which is, let's say, is already agricultural area or is grassland, and then you're just extracting from there. But on the other hand, if it's degrading agricultural area, there is also a problem because then we'll be impacting not only in terms of material extractions, but then we will be impacting potential for food production, which is also a different environmental and social impact. So these things are not mapped, so we don't have ways to do this type of inferences from these accounts. Here, the toxicity aspect we've talked about, and then there is also a problem of how detailed you can do this, like aggregating metal ores. There are so many metal ores, or even if you go for the same ore, there are different ways of that being produced, which you also don't know. Cool. That's a good idea. Our friend here suggests we could compare the food stuff based on calories of each product. I think that would be, if we look at, yes, if we look at supplying food for a whole population, then we are interested in the nutritional values of that. So that would be a useful way of comparing it, doing it by calories. And this reflects that depending on the end use, correct, you may choose different function, different reporting units depending on which is the intended use of that product. True. That's a good point. So that's it. In the end, today we saw three methods which are interrelated but look at different details. We have now so far looked at environmental or ecological footprints, carbon footprint, life cycle assessment, and these three accounting methods. We'll see many others in the classes to come. But here comes, well, which method to use? Possibly a combination of them if you want to do a more complete sustainability assessment. And you may find that maybe your indicators will be conflicting if you choose different methods. as we saw here with the when we change from that domestic material consumption to material footprint, then you see different behaviors of the in terms of coupling and decoupling. And then it depends on what you want to see. And as our colleague pointedly just presented here, also the functional units well, the functional units are right there, but the units service that you choose to report things or the scope of your analysis also may change depending on why you want to do it. I think it is very useful for us if you'd like to consolidate that. It's come back again over the lectures and making a glossary of terms if you're confused and you're making, because the names they look like each other, so it can be quite confusing, I agree. So if you just note it down, do your own schematics, your own division of things, it will help you organize. And but one thing that I think is pretty obvious for us is that we need to do some accounting. We need to not only do those accountings, but systematically improve them and standardize them and make sure we are talking about the same things and we're integrating these accounts. Because even if it is a system which is not perfect and then there are limitations, as long as we acknowledge those limitations, it's better to have something that we know what we're talking about than having no idea of what's happening. And why is that? Then we come back to the very first considerations that we had. It's like, in the end, in terms of sustainability, we want to conserve resources which cannot be renewed at the same rate we consume them. And we want to protect the environment against contamination and pollution. So, although material accounting does not completely capture all the aspects of these, but they are the physical basis. They are the starting point to understand this, right? So then it means these material accounting methods, they are a baseline, they are a starting point that can fit into more detail and multi-component, multi-view environmental assessments. And in the end is that, well, we all agree that we're consuming too much, right? Nature has, if you do different types of studies and you look different aspects of it, but overall, the indication is pretty clear that we're consuming too much. So if you look at reducing overall how much you consume, is already a very good start for then reducing the environmental impacts. It's like a parallel with, if you want to lose weight, ideally you will do a very detailed dietary plan and look at, well, which type of food I'm consuming, if I'm consuming too much calories and enough proteins and all of that, and then reassess. But as an initial point of view, it's like how much food I am having or how many calories I'm having to lose weight and how much calories I actually require. So it's basically like that. It's like a baseline benchmark for extraction from the environment and output of waste. So that's safely what we can say that these material accounting methods do. That said, we all acknowledge that they must be improved. As we see, we discussed like, well, how well we can characterize those hidden flows. Do we actually know? Are we using data for a few studies in different countries to characterize all the countries which may have different technologies which can perform either better or worse than the original studied ones? We also don't know. So that's it. This is just more of what I was saying. We now have our tutorials. You can have like your 5-minute break and come back to the tutorials at around 5 past 11. Any final questions before we wrap up? The content finished. Questions before we go to workshop? So yeah, just remember we have a quiz starting today. I forgot to mention about that. That is a quiz, and the quiz is set up in a way that if you go to the next question, you cannot come back to the previous one. That's been highlighted in the quiz instructions. And so yeah, be aware of that. Okay, so quiz today will be about SUS materials, carbon footprint, and LCA. Good. For those who go to my workshop, see you in a few minutes. For those who go to other workshops, enjoy it and see you next week. Bye bye. Thank you.